In this video, we will be finding common and binomial factors of quadratic expressions and factoring special quadratic expressions. When you factor, you can write a polynomial as a product of its factors. For example, if you had the number 6, then you could write it as a product of 2 and 3. This is what you would call prime factors. You can do the same thing with a quadratic expression as well. You can break it up into two linear factors in this case, x minus 4 times x minus 2, because if you were to FOIL these two factors, x times x gives you x squared, x times negative 2 gives you negative 2x, negative 4 times x gives you negative 4x, and negative 4 times negative 2 gives you a positive 8. The two middle terms should combine to give you the negative 6 and then positive 8. So it did work if you were to FOIL the factors back. Now, always, always, always look for common factors first, which is what we call the greatest common factor back in, I believe, 4th, 5th, 6th grade. For example, if you have this expression, if you notice in every one of these terms, there is an x that is in common, but you also have the number 4 in common. So if you factor out of 4, then you'll be left with x squared because you've pulled the 4 out front. And then if I pull out one x and there were 3 to begin with, then you would have 2 x's left. And then 4 times 3 is how you get the 12. So if you pull out a 4, then you're left with a 3. You have 2 x's, but if I pulled one of them out, that means I still have one of them left. And then 4 times what gives you 16, and it is 4. You pulled the x out front, and so there is no x on the inside with this 4, and then that is how you would factor that expression. Now, when the first term is a 1, then you would factor like we did in the very beginning. So we want to know what adds or subtracts to give you the middle term, and then what multiplies to give you the outside term. And so the way I teach is do a big X. What multiplies to give you this number, and what adds or subtracts to give you this number. And so the answer would be a negative 8 and a negative 9. Negative 8 and negative 9 add to give you negative 17, but they multiply to give you a positive 72. So the factors would be x minus 8 and x minus 9. In this example, again, if you do the big X, what multiplies to give you 25, and what adds or subtracts to give you a negative 10. And so your answer would be a negative 5 and a negative 5, because negative 5 plus negative 5 is a negative 10, but when you multiply them, you get a positive 25. So it'd be x minus 5 and x minus 5, which you could leave it like this, or since these are the exact same factors, then you could say it is x minus 5 squared, because this 2 represents that there are 2 factors that are the same. Now, when the first constant or the leading coefficient is not a 1, then this is where we have talked about in the past the illegal move. So here are the steps of the illegal move. First step is multiply the first times last. Multiply A times C, which would give you 15. And now factor like normal. So what multiplies to give you 15, adds or subtracts to give you negative 16? And the answer would be negative 15 and negative 1. And so you would get x minus 15 and x minus 1, because when you add them, you get negative 16. When you multiply, you get a positive 15. The third step is to undo the first step. The first step, we multiplied the first number times the last. So the last step is to undo that. So you're going to divide by A. And so you'll get x minus 15 times x minus 1, but A is 3, so we now divide those numbers by 3. This reduces to 5. This does not reduce, and so the 3 gets thrown in front of the x for your answer. So in this case, again, the first step is to multiply a times c to get negative 12. And then the middle number, we still add or subtract. So what multiplies give you negative 12 but adds give you negative 1? It would be negative 4 and a positive 3, because negative 4 plus 3 is negative 1, but when you multiply, you get negative 12. And so you'll get x minus 4 and then x plus 3. That is steps 1 and 2. We multiplied and we factored. Step 3, we now have to undo step 1. Step 1, we took the 6 and multiplied, and now we are going to do the opposite of that. So we are now going to divide by 6. Now you need to reduce first. 4 divided by 6 is 2/3, and 3 divided by 6 is 1/2. And now anytime you have a fraction that's left, throw it in the front of x. So this would be 3x minus 2, and this would be 2x plus 1. Special factors. You can have a perfect trinomial, or whether it's adding or subtracting. So for example, this is a perfect trinomial because this can be represented by 2x squared, and this could be represented by 3 squared. And then 2 times 3, right here, if you multiply the 2 times 3 to get 6 and double it, you do get 12. And so you can rewrite this automatically as a plus b and then squared. If you ever forget how to do that, you can also use the illegal move that you just learned. Because you have a number in front, you can do the illegal move, which is you multiply the first times the last, which gives you 36, and then you get 12. What multiplies to give you 36 but adds to give you 12? And the answer is 6 and 6. So you'll get x plus 6 times x plus 6. And then you got to undo that step. We had multiplied by 4 to begin with, so now we need to divide by 4 and reduce. 6 divided by 4 is 3/2. 6 divided by 4 is also 3/2. Anytime you have a fraction that's still left, you throw it in front, and you would get 2x plus 3 times 2x plus 3. And you have the exact same factors, and there's 2 of them, which is how you get the 2x plus 3 quantity squared. Same thing happens when you have subtraction. What squared gives you 9x squared? And it's 3x, because 3 squared is 9. And then what squared gives you 49? And the answer is 7 squared gives you 49. So this represents A, this represents B. 3 times 7 is 21, and if you double that, 21 doubled does give you 42. So this is a perfect square trinomial. So automatically your answer is going to be 3x minus 7, because there's a minus in, and then it's quantity squared. And in case you do forget how to do that, again, you can use the illegal move, and it will give you the exact same answer. The other special factors are a difference of squares. This is where you would have a perfect squared minus a perfect squared. So for example, what squared is going to give you 4x squared? And the answer is 2x. What squared gives you 49? The answer is 7. So this represents A, this represents B, and so automatically you would have A and B. One should be subtracted, one should be added. One's subtracted, one's added. So you would get 2x minus 7 and 2x plus 7. Again, what squared gives you 1? 1. And what squared gives you 100x squared? And the answer would be 10x, because 10 squared is 100. So this is A, this is B. So automatically, one should be a negative, one should be a positive. It doesn't matter which you put first. Just make sure that one's negative and one's positive. And then A is 1, and B is 10x. And there's your answer. Last, what squared gives you this? 4x squared gives you this. and 5y cubed. And so you'll have 4x squared minus 5y cubed, and you would have 4x squared plus 5y cubed. So at this point, I would like for you to pause the video, try to work these out on your own, and then resume in order to see me working them out. Okay, for this one, first thing you always do is see if there's anything in common. There is. You can pull a 2 out front. So if I pull out a 2, I'm left with 9x squared minus 4. At this point, you would sometimes normally stop because there's nothing else you can do. However, I noticed that this is a difference of squares. 9x squared is a perfect square, and 4 is a perfect square. So this actually can be reduced even further. I'm going to bring the 2 down front. And what squared gives me 9x squared? And the answer is 3x. And what squared gives me 4? And the answer is 2. So this would be 3x minus 2, and this would be 3x plus 2. On this one, at first I see that there's a number in front, so we'd have to do the illegal move. However, if you notice, every term can be divided by 3. So if I pull a 3 out front, then I'll be left with y squared plus 8y plus 15, because 3 times 8 is 24 and 3 times 15 is 45. And then this can be factored if you use the big X. What multiplies to give you 15 and adds to give you 8? And the answer is 5 and 3. So it would be y plus 5 and y plus 3. Now, in this last one, there's nothing in common. 3 does not go into 8 or 16 for that matter, and so we will have to do the illegal move. So I'm going to multiply 3 times 16 to get negative 48, and then adds to get 8. So what multiplies to give me negative 48 and adds to give me a positive 8? 12 and negative 4, because 12 minus 4 is 8, but 12 times the negative 4 is a negative 48. So we would write x plus 12 and x minus 4, but we're not done. Remember when we multiplied by our first number, we now had to undo that and divide by that first number. So now we are going to do the last step and divide by 3, and we reduce. 12 divided by 3 is 4. This does not reduce, and I have a fraction, so it needs to go in front of the x, and that will be your answer.